Hey guys, Miss Miklos here, and today we are going to be transitioning from solving quadratic functions into actually graphing them. So I want to start by focusing on this equation. Y equals A times the quantity x minus h squared plus k. We call this vertex form, and we will kind of see why we call this vertex form. And every single problem that we are dealing with in our lecture today and on the suggested problems with this lecture deals with this specific form. So everything will already be in that form. So we're going to start number one here by graphing, by filling in the XY chart and plotting those points. Because at this point in time, we really don't know how to graph a quadratic function. The only thing that we've paid attention to on quadratic functions are where the x-intercepts are. And today, to be honest, we don't really care about that. So I'm going to start by substituting in a value like -2. I know that when I substitute -2 into this function, I end up getting 4. So I'm going to plot my point of -2, 4 on my graph. Next, I'm going to try -1. And when I substitute that into our function, I end up getting the quantity -1 squared, which is 1. When I substitute 0 in, 0 squared is 0. And at this point, I can definitely tell this is not linear. It's not a straight line. Okay, it's forming some other type of shape. So I'm going to have to figure out what's happening over here in the positive x values. So I'm going to try 1. I know 1 squared is 1. And then I'm going to try 2. 2 squared is 4. So what I get is a shape like this. And I'm going to connect these now. And we always draw this with a U shape, and we call this a parabola. Okay, so the graph of any quadratic function is a parabola. And we're going to go ahead and talk a little bit more about a parabola now. So I need to figure out what we call the vertex. And the vertex is the point that is either a relative max or a relative min. And let me explain those further. We know relative means in relation to, so compared to other points around it, do we have a maximum value? So that means that something would be the highest point and would be falling on both sides. A relative minimum means that it is the lowest point in the area and it would be increasing on both sides. So if we look back at our graph over here, I do not have a relative max because to the right it keeps increasing. It never comes back down to give us a highest point. To the left it keeps increasing as well and never comes back down. So we do not have a relative max here. Instead, we have what we call a relative minimum. And that vertex is the ordered pair 0, 0. The other thing we notice about our graph is that it is symmetric. And we know symmetry means that it is like a mirror image. Okay, I just drew what we call the line or axis of symmetry. It's dashed because these are actually not solutions. But if I fold it on this line, these two sides would completely match up. This is always an equation, and in this case, it is the equation x equals 0. Okay, we know x equals lines are vertical lines. So x equals 0 means that it is a vertical line going through 0. So what might be helpful for you guys? We did this activity in class and it was kind of a hands-on activity where they used an app called Quick Graph. And these are just kind of some basic instructions as to how we graph using Quick Graph. And in class, the students used this to kind of make some connections. Okay, so this is going to be kind of a quick version of what that was like. So if we look at number 1, it says sketch or graph each of the following using a graphing application and sketch the graphs and label each. So when I graph all of these graphs, this is what it looks like. Okay, so f of x equals x squared, I labeled f, g of x, here we go, h of x up here, and k of x is down here. So we're noticing that this k value because if we look back at our original equation, that's what this means. Okay, it's a times x minus h squared plus k. This k value is affecting our graph in a certain way. In fact, we would say that this is affecting it as a vertical shift. So that means that it is making it move up and down. And to be even more specific, I'm noticing that when it's minus 1, it actually moves down 1. When it's plus 2, it moves up 2. When it's down 2, it moves down 2. So it's very specific in how it moves. So to be more exact here, if k was positive, we shifted up, and if k was negative, we shifted down. So that is definitely important for us to know. A positive k value means my graph's moving up. A negative k value means that my graph is moving down. So the next thing that we're looking at here is we're trying to figure out how this h value affects our graph. So those are all the numbers that are added or subtracted to x inside the parentheses. So when I graph these four functions, something kind of strange happens. Okay, here is our original function. We often call this the parent function. But I noticed for g, when I had plus 1 inside, it looked like it moves to the left 1. When I had minus 3, it looks like it moves to the right 3. And when I had plus 2, it looks like it moves to the left 2. So I'm thinking that this value of h changes our graph as a horizontal shift. But if we look closely at these, when h was positive, like in k and in function g, we notice that we moved the vertex to the left. When h was negative, we moved the vertex to the right. So what I want to do with this, I actually want to go ahead, and if we look at A, B, C, and D, we are going to identify what the vertex is without actually graphing. So for A here, okay, I notice this negative or this positive 2 inside. That means it is going to shift to the left 2, and I don't see anything added afterwards, so our vertex is going to be negative 2, 0. Our second one, I don't see anything inside the parentheses, so I'm going to put 0, but my k value this time is negative 1/7. Lastly, for C and D, for C, I have a negative 3 inside, so that means I'm going to have a positive 3, and I have an 8 as my k value. And for D, I notice that we have a positive 1 inside, so I'm going to have negative 1 as my h value and 2 as my k value. So we went ahead and found all these vertices. I want us to notice that this h value is always the opposite of what is inside the parentheses. Our k value is whatever this constant was. So we noticed that if we were going to graph all of these by hand, which we are, it would be a pain to go ahead and make an XY chart every single time. Right here, we're seeing that we can take some shortcuts because if it is in this form, we can quickly figure out what the vertex is. So with number 4 here, we are going to be taking a look at how the A value affects what our graph does. So let me go ahead and graph all of those. So when I graph all of these, I notice that the vertex stays exactly the same. The only thing that changes is the direction of our parabola and how wide our parabola is. So just kind of to match, x squared is this one right here where it kind of looks like it's going up 1 and over 1. Negative 1/2 is g right here where it looks fatter. It looks like we're going up, like down 1 and over 2 type of idea. If we look at this next one, 2, that's this one right here where it's skinnier. It's like we're going up 2 and over 1. K, once again, is skinny, but it's going down. And then M looks a little bit fatter. Today we are just sketching these graphs, so it's good for us to remember that a normal graph, what we're going to do, we're going to go up 1 and over 1. If something is fatter or wider, Since this is a sketch, we can do the same thing every single time, regardless of what the coefficient is. So a good way to do that is just to go up 1 and over 2. Lastly, here's one that's skinnier. So since we're sketching it, I'm going to go up 2 and over 1. So when we graphed, we need to figure out how does the value of a or negative a change the graph. And we saw it opened up if a was positive, and it opened down if a was negative. The other thing we determined was that when the absolute value of a was less than 1, the graph was fatty. And when the absolute value of a was greater than 1, that is when the graph was skinny. So now we're going to identify the vertex first and then sketch the graph. And I'm actually going to do it by hand. And it's okay that we're not going to be exactly sure how I'm getting this info yet because we're going to talk about that later. So y equals x minus 1 squared plus 2. We learned that my vertex comes from the h and the k values. So my vertex is 1, 2. So I'm going to go ahead and plot a point at 1, 2. I also think in this case my a value is 1 because I don't have anything here in front of my parenthesis. So that means it's going to go up. And I'm thinking it's going to be a normal graph. So my graph would look something like that. Looking at number 6, we actually have the same exact vertex, but what changes this time is that our a value is 3. So how this is going to affect our graph, I know it's still going up, but I'm going to go up 2 and over 1, because remember this is a sketch, it is not exact, and that is going to be my graph. Now, if you guys had gone up 3 and over 1 or up 4 and over 1, that's totally fine. Remember, this is just a sketch. Number 7 here, my vertex would be 3, negative 2. So I'm going to go to the right 3 and down 2. And this time, my a value is 1/4. So that means I'm going up, but it also means that it's going to be fatter. So I'm going to sketch what that would look like. Notice since it was fatter, I went up 1 and over 2, but just like we talked about, if you went up 1 and over 3 or up 1 and over 4, totally fine. And number 8, our vertex would be negative 3, 2. So I'm going to the left 3 and up 2. This time, our a value is negative 1/4, so that means that it is fatter, but it also means that it's going down. So that is just a sketch of what this would somewhat look like. So now we are getting into what I'm actually going to expect for you guys to be able to do on your homework tonight. Okay, I would also expect that you guys can complete something like this if that is given to you guys on a quiz next time. So in general, on every single problem we do, on our notes, on our quiz, on our homework, on our test, we are not only going to be sketching a graph, but we are going to be listing out these 4 characteristics. So the first characteristic that we are going to be talking about is the vertex. And our vertex is HK. And we learned that that's coming from these 2 values. Notice this is minus h. That's why this is always the opposite. So when it said x minus 2, we put a 2. If it said x plus 5, we put negative 5. Our second characteristic is about how the parabola is opening. If a is greater than 0, it is up. If a is less than 0, then it's going down. The third one is going to be about the width of our graph. We say if the absolute value of a is equal to 1, that it is normal. If the absolute value of a is less than 1, then we say that is fatty. And if the absolute value of a is greater than 1, we call it skinny. And notice that it is absolute value, so even if it's -3, that would be something that is skinny because the absolute value is greater than 1. Lastly, our axis or line of symmetry is always a vertical line. Okay, it's x equals h, not just h, because I know that it is going to be a vertical line that is going to be going straight up and down through the vertex. Notice that this h value is the h value in our vertex. Okay, so our first problem. Well, first of what I would expect you guys to do on your homework tonight. Y equals 2 times the quantity x minus 3 squared plus 4. This is already in vertex form. So I know that my vertex is 3, 4. My a value here is 2. So since 2 is positive, I know it's going up. Since the absolute value of 2 is greater than 1, I know that this is going to be skinny. And my line of symmetry is going to be the equation x equals 3. So I'm going to go up to 3, 4. Since it's up and skinny, I know I'm going to go up 1 and over 1. I'm sorry. I did it right. I said it wrong. I'm going up 2 and over 1 in both directions. And when I go ahead and sketch that, it would look something like this. And then I'm going to sketch my line of symmetry. Notice my line of symmetry is a dashed line. And that's because those are not actually solutions to this function. Okay, number 10, y equals 2 times the quantity x plus 3 squared plus 4. I know my vertex this time is -3, 4. Our a value is 2, so it's going up, and it is skinny. And my line of symmetry this time is x equals -3. So I'm going to go to -3, 4, and then I'm going up 2 and over 1. Okay, whenever I'm drawing my U shape, I'm also putting arrows because I know it is continuing. And now I am sketching my line of symmetry. Okay, these characteristics might seem really familiar to you because we used them when we talked about absolute value graphs. However, in absolute value graphs, I really didn't care that much that we listed all these out. There are more to help you. Today, this is essential. Okay, I need to list out those 4 characteristics on every single problem. Number 11 looks kind of strange because it's y equals 1/2 x squared minus 1. We might get a little freaked out because I don't see any parentheses here, but that just means that the x value of my vertex is 0. So my vertex is 0, -1. My a value is 1/2, so it's up, and it would also be fatty because we have a fatty fraction. And my line of symmetry is x equals 0. So I'm going to I'm going to 0, -1. Since it's up and fat, I'm going to go up 1 and over 2 in both directions. And I'm going to sketch my line and sketch my line of symmetry. Number 12 is another one that looks kind of strange. Y equals -3x squared. This time my vertex is 0, 0, because I don't have anything inside the parentheses, so that's why I have 0 for my x value. And I don't have anything after. I don't have a constant I'm adding, so that's why my y value is 0. My a value this time is -3, so that is going down. It would be skinny because the absolute value of -3 is less than 1. Is greater than 1. And our line of symmetry would be x equals 0. So I'm starting at 0, 0, and since it's skinny, I'm going to go down 2 and over 1. Notice as soon as I have these characteristics, I really don't even need to look at the equation to graph it. I'm just going off of what I wrote down here. And I want to stress one more time, would it be okay if you went ahead and instead of going down 2 and over 1, you went down 3 and over 1 or down 4 and over 1? Definitely. What I'm trying to display is that this is skinnier than our normal parabola. 13 looks a little strange because it does not look like it's in the right form, but we are intelligent honors algebra 2 students. And we know the only thing we need to do is move 4 to the other side. So I added 4 to both sides there. So now if I'm going through this, I know that my vertex is 0, 4. Our A value here is -1. So that means it's going down, and it is normal. And my line of symmetry would be x equals 0. Okay, so there is 0, 4. If it's down and normal, I'm going to go ahead and put those points and sketch my line of symmetry. So I'm hoping you guys can see that this is extremely repetitive. It's really just learning how do we find these characteristics. Last problem, number 14, f of x, f of x, that looks scary, but we know all that means is y. Equals 1/3 times the quantity x plus 2 squared plus 1. So I know that my vertex is -2, 1. Our A value is 1/3, so that means it is up and it is fatty. And my line of symmetry would be x equals -2. So there's -2, 1 up, and fatty means it's up 1 and over 2 in both directions. So I'm going to go ahead and sketch that. And then sketch my line of symmetry. So hopefully this gives us a really good idea of how we need to graph our quadratic functions. Every single problem, I should see you guys writing these 4 characteristics before we sketch the graph. Tonight on our suggested problems and on your homework quiz, every single problem is going to be in this form, which is really nice. The next lecture, we are going to learn what to do when it is not in this form. So that's all for now.